Hey guys, my name is Eric. This is week 5 DP video for Buck Sporting Goods. This week's question: imagine you are the chief financial officer of a large sporting goods company, Buck Sporting Goods. Every few years, new retail stores open up in various parts of the country. Your current job is to determine, based on market research, where to open your next retail outlet. Your team of analysts have narrowed down the location of the next store to 3 counties. The counties currently have populations of 2.4 million for Alpha County, 2.7 million for Beta County, and 2.05 million for Gamma County. Based on analysis of the last few years of population change, it is estimated that the population of Alpha County will decrease by 100,000 per year. Beta County will decrease by 4% per year. And Gamma County will increase by 2% per year. Your plan is to break ground on construction in exactly 4 years. If it is your goal to build the store in the county with the largest population size, where would you plan on building and why? What if the economy causes the groundbreaking to be postponed 2 additional years? Now, for Alpha County, it's pretty straightforward. It's a linear equation. In this case, let's y equal the years and p equal the population. 2.4 million at a decrease of 100,000 a year simply looks like so: 2.4 million minus 100,000 times y equals p, y being the years, p equaling population. Written out, it looks this way: 2.4 million minus 100,000 times 4 equals 200,000. Now, we extend that a little bit longer for 2 more years. You guessed it, we'd put a 2 for y, starting with 2 million minus 100,000 times 2 equals 1.8 million for the additional 2 years. Now for Beta County, it's a little more interesting. You're looking at the decay formula. So for decay formula, in this case, let y is equal to p, where y is p. A is the initial population. 1 represents 100%. B is the decay factor, and X is the years. So if we look at it like this, if we have 100% minus 4%, that leaves us with an initial or an original decay factor of 0.96 written out in decimal form, which is 96%, right? So what we would do is look at it this way: 2.7 million times 0.96 raised to 4 years. You're looking at 2,293,235.71. Now, can't get 0.71 person, so 0.71 is basically 236, so we'll round up, I guess. If the construction is delayed 2 more years, you simply would just plug in the 2 years, but use the 4-year population. That makes sense? Because what you're looking at is you're not going to go back to 2.7 million. You're going to go to the original 4 years, back to the 4 years total that you have: 2.235.71 times 0.96 decay factor raised to the 2 more years gives you 2,113,446.03 of a person. So moving on to Gamma County. Gamma County is a little more tricky. Basically, what we will be doing is increasing 2% every year plus the original total of the population. It's basically represented this way. So 2.05 million times 1, which represents the original whole total population, plus 2% of that, raised to the 4 years that we're looking at. So it'd be written out this way. And if you, here's a little explanation on that, where 1 is the initial population plus the 2% as a decimal raised to the power of the years. Now that said, 2.05 million times 1 plus 0.02 raised to the fourth power, which is the 4 years, you're looking at 2,218,985.93 of a person. Postpone 2 more years. You're using the 4-year total times 1 plus 0.02 raised to 2 more years gives you 2,308,632.96. So all that being said, as CFO, I'm looking to break ground in Gamma County with a 2% rate of increase in population yearly. Initial population 2.05 million. Written out in function form, 4 years, you're looking at 2,218,985.93. And then if extended for 2 more years, looking at 2,308,632.96. Now, this week was actually really fun. It's really fun to actually know, really have a firm grasp on how these functions work. So it was really fun for me to actually put that together. That being said, if you have any questions, feel free to reach out. Thank you again for the opportunity. Milos, Mr. Podmonic, and I'll be sending that over shortly. Thank you so much. Have a great year.